Again. Yes, I'm recording. All right, so I was saying, so satisfied given the student is sophomore, and then do you hear me well, guys? I mean, it works fine.
Yeah.
Yes,
Okay.
it works.
Okay. Okay. All right. So then you have a probability that the student selected at random. He's actually junior or neutral. Okay. So from the table, junior and neutral, right? So how many neutral and junior students do we have? So you can take a look to the table. So first, so this is probably that the student selected at random is junior or neutral. So we need to apply a probability rule because it's or, right? So that will be probability that the student is junior plus probability that the student is neutral, right? Minus probability that the student is junior and neutral. So just to remind you the formula in general. So if you have probability that probability of A or B, so there'll be probability of A plus, because it's or, plus probability of B minus probability of A and B. All right. So in our case, so first probability that the student is junior, right? Probably that student is junior. So we count how many juniors we have here. So in total, we have 98 junior students over the size of the sample. That's 417 plus. So how many neutral students? In total, we have 166 neutral students minus junior and neutral. So at the same time, the student is junior and neutral.
32.
32. Yeah, thank you. 417. Right. So then the answer is 98 plus the 166 minus 32 over 417. Okay. Right. For satisfied and freshman, probably that the student selected at random is satisfied and freshman. Okay, so how many students are satisfied at the same time, satisfied and freshman? So if you take a look to your table, you see there's a freshman, and then here you have satisfied, right? And then so the number of students satisfied and freshmen at the same time is actually 23. 23, right? So it's 23 over, of course, the size of the sample, which is 417. Last one. That's probability that the student is senior, given that the student is not satisfied. The student is not satisfied. Oh, sorry, is not satisfied here. Is not satisfied. Right? So the student, it's not a random student, it's a student who's not satisfied, right? Right, so the size of the sample would be the number of not satisfied students. And so how many not satisfied students in total? We have 71. So we need to divide by 71, right? Because we know that the student is not satisfied. It's not a random student. It's a student who's not satisfied. And you have 71. Now, among the 71 students, how many are senior? Not satisfied, right?
12.
12. So then that's 12 over 71.
Question for you, Professor.
Yes.
Professor, if you record, will you still have the echoing? You already recorded, correct?
Yes, yes.
Oh.
I'm recording, yeah. I don't know, for some reason I have this echo. I don't know how to fix the problem, actually. I'm sorry about that.
Sure. Okay.
I don't know what's going on. All right, we can do, I guess, number 2. So number 2, that's a binomial experiment, right? So we have this study which shows that 10% of all businessmen who wear ties wear them too tight, right? So right down here, 10%. All businessmen. So who wear ties, wear them too tight. So at a board meeting of 6 businessmen, right? All of whom wear ties. What's the probability that exactly 3 ties are too tight? So when you select a businessman at random, okay, so there is, so P, so that's the probability of success. So this is when a businessman wears ties, which is too tight, right? This is, so the businessman wears a too tight tie. Okay. So we know that because of this study, we know that 10% of all businessmen who wear ties wear them too tight. So the probability of success here that a businessman selected at random who wear ties wear them too tight is 10%. So this is probability of success P is 10%. Okay. Now at this board meeting, we have 6 businessmen, right? So the number of trials is 6. So N so this is P, this is number of trials. This is equal to 6, right? Because we have 6 businessmen. So what's the probability that exactly 3 ties are too tight? So for number 1, so we need a probability that R is exactly 3. So R here, that's the number of successes. This is the number R, that's the number of successes. Okay. So in number 1, we need exactly 3 ties, which are too tight. Okay, so we need number of successes equal to 3 in number 1. So here we can use the table number 2. Okay, the number of trials in total, we have 6 businessmen, so the N is 6. The probability of success P is the 10%, right? And number of successes is 3. Okay, so if you check this table number 2, N is 6. So N is 6 and R is 3. So, in this table number 2, you have like N, this is like 2, then 3, 4, etc. And then you have like 6. And next to 6, you have like, that would be your R, number of successes. Right? So next to 6, you have like 0, 1, 2, 3, 4, 5, 6. Okay, and we need R to be equal to 3 in this problem number 1, right? And then there's a probability of success, P. So here in the top, you have your P, and you can see here we have like 0.01, 0.05, 0.10. So we need our P to be equal to 10%. So 10%, that's 0.10. Okay, so our P is 0.10. So here you're gonna get your answer. So R is 3 and P is 0.10. So that will be, where is it? That's a 0.015. So here we have 0.015. So probability that R's number of successes is 3 is 0.015. In other words, that's 1.5%. If you take 2 digits after the decimal point. Now let me move to the next. So at most 2 ties are 2 tied. At most 2, no. So it means at most 2. It means no more than 2. Okay, so for number 2 here. So when we say at most 2 ties, at most 2, that's no more than 2. And no more than 2 means it's less or equal to 2. Less or equal to 2 means it's 0 or 1 or 2. Okay. So in this problem, we need the probability that R, number of successes, is 0 or 1 or 2. Okay. So this is actually probability that R is 0 plus, okay, because we have OR. So there'll be a plus. That R is 1. And then again, OR. So that's plus, another plus. That R is number of successes is 2. And again, here you can use the table, our table number 2. So this is table number 2. Okay. So for 0, you can find, so the P and N doesn't change, right? The P and N, the P, which is 10%, and the N is 6, they don't change. So here you can get probably that R is 0. Then next, you're gonna get probably that R is 1, and then here you can get probably that R is 2. For the next one, it says at least 4 ties are 2 tied. So at least means, so number 3. So at least 4. So that means the minimum is 4. So it's 4 or more than 4. Okay, so it's 4 or more. Okay, so because in total we have 6 businessmen, right? So 4 or more, that will be 4 or 5 or 6. Okay. So that's the probability that R is 4 or 5 or 6. So that's probability that R is 4 plus probability that R is 5 plus probability that R is 6. Okay, and again, use the table. Number 2. You know your N, it's 6. You know your P, probability of success is 10%, is 0.10. And then you can find probability that R is 4 just right here. This is where R is 5, and this is where R is 6. Any questions so far, guys? So hopefully you know how to use this table number 2.
Hi. After the Zoom meeting, can we speak while everybody leaves? This is Kathleen, by the way.
Okay, sure.
Thank you.
Next, you need to find the probability distribution of this binomial experiment. So the binomial distribution means you need to find, so this is number 4. So binomial distribution. So the variable of the binomial distribution is not X, it's R, the number of successes. And then you need to find the probability of R. R, of course, number of successes, because in total we have 6 businessmen, right? So R goes from 0 to 6. So you can have R0, R1, 2, 5, and 6. Okay, so then you can just use the table number 2. So for example, for R0, this is point, I think 531. This is 0.354, 0.98, 0.015. This is 0.001 actually. This is 0.000, and then 0.000. So what I'm saying here, guys, is that so this is probability that R is 6, probability that R is 5, R is 4, and probability this is probability that R is 3, etc. All right, so we have like 3 minutes. What's the expected number of ties too tight? Number of ties too tight. When you see the word expected number, it means the mean. So the expected number, that's the mean. Which is mu, right? And the mean of binomial distribution, it's n times p, just n times p. And that's the number of trials. We have 6 businessmen times probability of success, which is 10%. Okay, so then the answer, of course, would be 0.6. So that's the expected number of ties too tight. Now there's the standard, where is it? Yeah, the standard deviation of the distribution. So this is, again, this is a binomial distribution. So the standard deviation is, just to remind you the formula. So sigma. So that's equal to square root of n times p times q. Where q, that's the probability of failure. So that's actually 1 minus p. Right, that's the probability of failure. Yeah, so in our example, of course, n is 6, p is 10% or 0.10, and so q would be 1 minus p, so 1 minus the 0.10, so that's 0.90. Right, so sigma, that's square root of 6 times point or 0.10 times 0.90. Right. So don't forget, guys, first you have to do what's under the square root, right? So like here under the square root, you have like this, 6. You have 6 times the 0.10 times the 0.90. So that'll be equal to, so this is 6 sigma equals square root of 0.54. Okay, the 0.54, that's the what's under the square root, this thing here, right? And then you need to apply the square root to the 0.54. Okay, so that'll be equal to square root of this. That'll be equal to 5. Sorry, not 5, but 0. Let me check my notes. Yeah, it's 0.73.
Mhm.
Okay. All right, guys. I have to stop here, I guess. Sorry for this the problem with the Zoom. I mean, happens sometimes. But yeah, so I have to stop here, I guess. And thank you for listening. And I will see you on Wednesday. And of course, if you have any question about the review sheet, you can email